I am Parkavi, Assistant Professor of Mathematics in Erode Sengundar Engineering College. Now we discuss about probability and random process. Probability means the probability distribution for a random variable describes how the probabilities are distributed over the values of random variable. The definition of probability is denoted by the probability denoted by P of A is equal to N of A by N of S. Here N of A is number of favorable outcome and N of S is total number of outcome. Next definition, random process. Number of favorable outcome with time t, that is x of s comma t. Random process only occur in favorable outcome. Next one, application of probability and random process. First one is signal process. Second one is digital communication, communication process, wireless communication and information technology. Next we see the definition, conditional probability. The probability A of a event A depending upon the event B, it is called probability of A. That means the event A is dependent on the event B. We denoted by P of A divides B is equal to P of A intersection B divided by P of B. And the event B depending on the event A, we denoted by P of B by A equal to P of A intersection B divided by P of A. Next one is definition of random variable. A random variable x, we denote the random variable x, that a numerical value to each possible outcome of an experiment. Next one is random variable occur in two types. First one is discrete random variable and another one is continuous random variable. First we see discrete random variable. A random variable x is said to be discrete random variable if it takes finite or countably infinite value. That means the random discrete random variable takes only a finite and countably infinite value. Countably infinite means we know the next value. That means countably infinite. Next we see the definition, probability mass function. Let x be a discrete random variable which takes the value, x takes the value x1, x2, etc. or at most a countably infinite value. The probability mass function denoted by P of xi is equal to P of I. The probability mass function satisfies two conditions. First one is P of xi greater than or equal to 0 and summation I equal to 1 to infinity P of xi is equal to 1. Next definition is cumulative distribution function. The cumulative distribution function is denoted by f of s, capital F of x. It satisfies the condition capital F of x is equal to P of x less than or equal to x. Next we see mean and variance. Let x be a discrete random variable. Assume the value x varies from x1, x2, etc. xn and the probability p1, p2, etc. pn. The mean is denoted by E of x. E of x means expected value of x. E of x is equal to summation I equal to 1 to n xi p of xi is called expected value of x. Next we see variance. Variance means variance of x is equal to E of x square minus E of x the whole square. Here E of x means summation I equal to 1 to n xi p of xi. Here E of x square means summation I equal to 1 to n xi square p of xi. The variance of x, that means standard deviation is equal to square root of variance x. First we see the problem based on discrete random variable. The first problem, a random variable x has the following probability distribution. X varies from 0 to 7 and the probability value 0k, 2k, 2k, 3k, k square, 2k square, 7k square plus k. First we find the value of k and the smallest value of x for which p of x less than or equal to x greater than 1 by 2. That means to find the smallest value. And the next condition is p of 1.5 less than x less than 4.5 divides x greater than 2. First we find the value of k. We have to use probability mass function and the formula is summation I equal to 1 to infinity p of xi is equal to 1. Here the x varies from 0 to 7. So summation k equal to 0 to 7, p of xk is equal to 1. We add the all probability values, that means 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k is equal to 1. So we add all k square, 10k square plus k means 9k minus 1 is equal to 0. Here we use quadrature formula. That means k is equal to minus b plus or minus square root of b square minus 4ac by 2a. Here b is 9 and a is 10, c is minus 1. So we apply minus 9 plus or minus square root of 81 minus 4 into 10, c minus 1 divided by 20. So minus 9 plus or minus square root of 81 plus 40 by 20. So minus 9 plus or minus square root of 121 divided by 20. We take square root on 121, we get 11. So minus 11 minus 9 plus or minus 11 divided by 20. Plus or minus we add and subtract 2 times. 9 minus 9 plus 11 by 20 comma minus 9 minus 11 by 20. So we get 2 by 20 and minus 20 by 20. So k is equal to 1 by 10 comma minus 1. Here minus 1 is the negative value. The condition of probability mass function is p of xi greater than or equal to 0. So we neglect the value of minus 1. We take k is equal to 1 by 10. So first we find the value of k. Next we find the smallest value of x for p of x less than or equal to x greater than 1 by 2. Here we have to use distribution function. Distribution function is f of x is equal to p of x less than or equal to x. First we apply the value of x value. First to apply 0. F of 0 is equal to p of x less than or equal to 0. So p of 0 is equal to 0. Next we apply f of 1. That means p of x less than or equal to 1. So here 0 and 1 value occur. Therefore p of 0 plus p of 1 is equal to 1 by 10. Next p of f of 2. So here 0, 1, 2 occur. So p of 0 plus p of 1 plus p of 2. So the value of p of 0 is 0 plus 1 by 10 plus 2 by 20 is equal to 3 by 10. Next we apply 3, f of 3. So here p of 0, p of 1, p of 2, p of 3 occur. So we get 1 by 2. Next f of 4 is equal to p of x less than or equal to 4. Here f of 0, p of 0, p of 1, p of 2, p of 3, p of 4 occur. So the value of f of 4 is equal to 4 by 5. Therefore it's greater than 0.5. So therefore x is equal to 4 is the smallest value of p of x less than or equal to x greater than 0.5. Next we discuss the third one. P of 1.5 less than x less than 4.5 divides x greater than 2. We have to use conditional probability. The conditional probability is p of a divides b is equal to p of a intersection b divided by p of b. So we use the formula here. P of 1.5 less than x less than 4.5 intersects x greater than 2 divided by p of x greater than 2. So x varies from 2, 2.5, 3, 3.5 only and 4. So intersection of x greater than 2 means 0 and greater than 2 means 3, 4, 5, 6, 7 occur. P of x greater than 2 means p of 3, p of 4, p of 5, p of 6, p of 7. So we get the intersection of these values. We get p of 3 plus p of 4 divided by 2k plus 3k plus k square plus 2k square plus 7k square plus k. So p of 3 means 2k, p of 4 is 3k. 2k plus 3k divided by, we apply the k value, k is equal to 1 by 10. We get 2 by 10 plus 3 by 10 divided by 2 by 10 plus 3 by 10 plus 1 by 100 plus 2 by 100. So we get 5 by 10 divided by 7 by 10. We take reciprocal. We get 5 by 10 into 10 by 7. So 10 and cancel is equal to 5 by 7. Therefore, P of 1.5 less than x less than 4.5 divides x greater than 2 is equal to 5 by 7. Next we see the problem. Find the probability mass function of a random variable x defined by p of x, x is 3c squared, x is equal to 1 is equal to 4c squared, and x is equal to 2 is 5c minus 1. Here we find the x value is x varies from 0, 1, 2, and the probability value 3c squared, 4c squared, 5c minus 1. Now we find the value of c and the distribution function of x and the largest value of x for which f of x less than 1 by 2, and fourth one is p of 0 less than x less than 2 divides x greater than 0. Here x varies from 0, 1, 2, and p of x value is 3c square, 4c minus 10c square, and 5c minus 1. First we find the value of c. So we have to use the probability mass function formula. The formula is summation I equal to 1 to infinity p of xi is equal to 1, and therefore the I varies from 0 to 2. So summation I equal to 0 to 2 p of xk is equal to 1. So we add the all probability value 3c square plus 4c minus 10c square plus 5c minus 1 is equal to 1. So minus 7c square plus 9c minus 2 is equal to 0. We use the quadrature formula to find c value. C is equal to minus b plus or minus square root of b square minus 4ac by 2a. Here the b value is 9 and a is minus 7 and c is 2. So we apply the value minus 9 plus or minus square root of 9 square means 81 minus 4 into minus 7 minus 2 divided by 2 into a value minus 7. So minus 7 plus or minus 9 plus or minus square root of 81 minus 56 divided by minus 14. So minus 9 plus or minus 81 minus 56 is 25 divided by 14. So square root of 25 is 5. Minus 9 plus or minus 5 by minus 14. So we get c is equal to minus 9 plus 5 divided by minus 14 and minus 9 minus 5 by minus 14. We get minus 9 plus 5 is minus 4. Minus 4 by minus 14 and minus 14 by minus 14. So we get c is equal to 2 by 7 and 1. Here we c is equal to 1 is not possible because the probability value is equal to 1. So we take the value c is equal to 2 by 7. To apply the value of c in probability values, we get p of x is equal to 12 by 49, 16 by 49, 3 by 7. Next we use the distribution function. Distribution function, the formula is f of x is equal to p of x less than or equal to x. So first we apply 0, 1, 2 the value. F of 0 is equal to p of x less than or equal to 0 means p of 0. The value of p of 0 is 12 by 49. Next apply f of 1. F of 1 means p of x less than or equal to 1. So here occur p of 0 plus p of 1. Therefore p of 0 is 12 by 49 and p of 1 is 16 by 49. We get 28 by 49. Next f of 2 is equal to p of x less than or equal to 2. Here we get p of 0, p of 1 and p of 2 to apply the value. Next we find largest value of x for which f of x less than 1 by 2. So we check the value of 0, 1, 2 in the probability function. We get greater than 1 by 2, the value is largest value. First we check the distribution function. F of x is equal to p of x less than or equal to x. First we put x is equal to 0. So f of 0 is equal to p of x less than or equal to 0. So x less than or equal to 0 means p of 0. P of 0 is equal to 12 by 49. To divide the value we get 0.24. Next apply x is equal to 1. So f of 1 is equal to p of x less than or equal to 1. X less than or equal to 1 means p of 0 plus p of 1 occur. So p of 0 is 12 by 49 and p of 1 is 16 by 49. So we get 28 by 49. The fraction of 28 by 49 is 0.57. So therefore x is equal to 1 is the largest value. Next we check p of 0 less than x less than 2 divides x greater than 0. So we have to use conditional probability. The conditional probability formula is P of A divides B is equal to P of A intersection B divided by P of B. Here A is 0 less than x less than 2 and B is x greater than 0. So apply P of 0 less than x less than 2 intersection x greater than 0 divided by P of here B is x greater than 0. So P of x greater than 0. 0 less than x less than 2, the value is 1 and intersection x greater than 0 means 1 and 2. So 1 intersection 1 comma 2, the common value is 1. So P of 1 divided by P of 1 plus P of 2. P of 1 value is 16 by 49 and divided by P of 1, 16 by 49 plus P of 2 is 3 by 7. So we get 16 by 49 divided by 37 by 49. So to take reciprocal, 16 by 49 into 49 by 37, we get 16 by 37. So P of 0 less than x less than 2 divides x greater than 0 is equal to 16 by 37. Next problem. The probability function of an infinite discrete distribution. Here the distribution function is infinite, given by P of x is equal to j is equal to 1 by 2 power j. J varies from 1 to etc. That means to infinity. So here mention infinite discrete distribution. First we find mean of x. Second one is P of x is even number. And third one, P of x is divisible by 3. First we take P of x is equal to j is equal to 1 by 2 power j. First we find mean. The mean is expected of x value. That means E of x is equal to summation j equal to 1 to infinity xj P of xj. Here also j varies from 1 to infinity. So we take the same value. Summation j is equal to 1 to infinity xj into P of xj means given 1 by 2 power j. First we apply j is equal to 1. So we get x1 into 1 by 2 power 1. Next apply 2 plus x2 1 by 2 square. Next apply 3 plus x3 1 by 2 cube plus etc. So the x1 value is 1. X2 value is 2, x3 value is 3 plus etc. So apply the value 1 of 1 by 2 plus 2 into 1 by 2 square plus 3 into 1 by 2 cube plus etc. Here the common term is 1 by 2. So we take 1 by 2 in common. So we get 1 plus 2 into here 1 by 2 square. So 1 by 2 is here. So 2 into 1 by 2 plus 3 into 1 by 2 the whole square plus etc. Here we use the binomial formula 1 minus x whole power minus 2 is equal to 1 plus 2x plus 3x square plus 4x cube plus etc. Here to apply x is equal to 1 by 2 we get the same term. So we apply the formula. We get 1 by 2 1 minus x is 1 by 2. So 1 minus 1 by 2 whole power minus 2. To fraction 2 minus 1 by 2 whole power minus 2. 2 minus 1 1. 1 by 2 the whole power minus 2. 1 by 2 divided 1 by 2 into 1 by 2 square 4 the whole inverse. So apply the inverse 1 by 2 into 4. 4 in 2 2's are 4. So we get is equal to 2. The mean value of x is 2. Next we find P of x is even. So we take only even numbers. Even numbers 2, 4, 6, 8 etc. Here P of x is even is equal to take the even number P of x is equal to 2 plus P of x is equal to 4 plus P of x is equal to 6 plus etc. So P of x is equal to 2 means 1 by 2 square. That means P of x is equal to j means 1 by 2. Here x is equal to 2. We get 1 by 2 squared plus 1 by 2 power 4 plus 1 by 2 power 6 plus etc. So the common term is 1 by 2 squared. So we take 1 by 2 square in common. We get 1 plus 1 by 2 square plus 1 by 2 power 4 plus etc. So 1 by 4, 1 by 2 square is 1 by 4. 1 plus 1 by 2 the whole square whole power 1. 1 by 2 square the whole square means 1 by 2 square is 4. So 2 power 4 means 2 square the whole square means. So 1 by 2 square the whole square plus etc. We apply the formula 1 minus x the whole inverse is equal to 1 plus x square plus etc. Here x is equal to 1 by 2 square. So apply the formula 1 by 4 into 1 minus, here x is equal to 1 by 2 square. So 1 by 2 square means 1 by 4. 1 minus 1 by 4 the whole inverse implies 1 by 4 into 4 minus 1 means 3. 3 by 4 the whole inverse. So p of x is even is equal to 1 by 4. We take the reciprocal, we get 4 by 3. 4 4 cancel. So p of x is even, we get p of x is even is equal to 1 by 3. Next, to find x is divisible by 3. So p of x is divisible by 3 means we take the divisible value of 3 is 3, 6, 9, 12, etc. So now we take p of x is equal to 3 plus p of x is equal to 6 plus p of x is equal to 9 plus etc. So here p of x is equal to 1 by 2 power z. We apply z is equal to 3. We get 1 by 2 cube plus 1 by 2 power 6 plus 1 by 2 power 9 plus etc. So the common term is 1 by 2 cube. So we take common in 1 by 2 cube. We get 1 plus 1 by 2 cube plus 1 by 2 power 6 plus etc. 1 by 2 cube value is 1 by 8. So 1 by 8 into 1 plus 1 by 2 power 8 the whole power 1 plus 1 by 2 cube the whole square etc. Here we apply the same formula. 1 minus x the whole inverse is equal to 1 plus x squared plus etc. Here x is equal to 1 by 2 cube. So we apply 1 by 8 is common term. So 1 by 8 into 1 minus x is equal to 1 by 2 cube means 1 by 8. So 1 minus 1 by 8 the whole inverse. 1 by 8 into 8 minus 1, that means 7 by 8 the whole inverse. We take the reciprocal 1 by 8 into 8 by 7. So 8 cancel is equal to 1 by 7. So p of x is divisible by 3, we get 1 by 7. Next problem. The probability mass function of a random variable x is given by p of x is equal to r is equal to k of r cube. Here r varies from 1, 2, 3, 4. Now we find the value of k and conditional probability value. That means p of 1 by 2 less than x less than 5 by 2 divides x greater than 1 and also find mean and variance. First given p of x is equal to r is equal to k r cube. R varies from 1, 2, 3, 4. So we take r varies from 1, 2, 3, 4. P of x is equal to 1 we get k and 2 we get 2k, 27k, 64k. First we find the value of k. So we use the probability mass function formula summation I equal to 1 to infinity p of xi is equal to 1. So here I varies from 1 to 4. So summation r equal to 1 to 4 p of xr is equal to 1. We add all probability values k plus 8k plus 27k plus 64k is equal to 1. So add all k value, we get 100k is equal to 1. So k is equal to 1 by 100. So we apply the k value in p of r function. We get 1 by 100, 8 by 100, 27 by 100, 64 by 100. First, second we check the value p of 1 by 2 less than x less than 5 by 2 and divides x greater than 1. So here we use conditional probability formula. The conditional probability formula is p of a divides b is equal to p of a intersection b divided by p of b. So apply here 1 by 2 less than x less than 5 by 2 is a value and x greater than 1 is b value. So apply p of 1 by 2 less than x less than 5 by 2 intersection x greater than 1 divided by p of b means p of x greater than 1. So 1 by 2 to 5 by 2 the x value is 1, 1.5 and 2. Intersection x greater than 1 means 2, 3, 4. So the intersection of 1, 1.5, 2 and the common value is 2. So we get p of 2 divided by p of 2 plus p of 3 plus p of 4. The value of p of 2 is 8 by 100. So 8 by 100 divided by P of 2 is 8 by 100 plus P of 3 is 27 by 100. P of 4 is 64 by 100. So 8 by 100 divided by the total is 99 by 100. We take reciprocal 8 by 100 into 100 by 99. 100 cancel. So we get the value 8 by 99. Next we find the mean. Mean value is, the formula is E of x is equal to summation j equal to 1 to infinity xj p of xj. So we apply the value 1 to 4 j. So we get, first we apply 1 x1 p of x1. Next x2 p of x2 plus x3 p of x3 plus x4 p of x4. The previous problem we have the same term. To apply x1 is equal to 1, x2 is equal to 2, x3 is equal to 3, x4 is equal to 4. Here the same value to apply. X1 is 1, P of x1 is 1 by 100 plus 2 into 8 by 100 plus 3 into 27 by 100 plus 4 into 64 by 100. So we get 1 by 100 plus 8 into 2, 16. 16 by 100 plus 27 into 3, 81 by 100. 64 into 4, 256 by 100. So we get 354 by 100. So the mean value is E of x is equal to 354 by 100. Next we find variance. The variance formula is variance of x is equal to E of x square minus E of x the whole squared. So E of x square formula is summation j equal to 1 to infinity xj squared into p of xj. Here j varies from 1 to 4. So apply the value first to 1. x1 squared into p of x1 plus x2 squared into p of x2 plus x3 squared into p of x3 plus x4 squared into p of x4. Here x1 square, x1 means 1. So 1 square 1. P of x1 is 1 by 100. So 1 into 1 by 100. x2 square means, that means 2 squared. So we get 4. 4 into P of x2 is 8 by 100. Plus 3 square means 9. So plus 9 into 27 by 100. Plus 4 square means 16. So 16 into 64 by 100. So 1 by 100 plus 8 into 4, 32. 32 by 100. 27 into 9 are 243 by 100. 64 into 16 is 1024 by 100. To add the all value, we get 1300 by 100. And now we find E of x square. So apply the formula variance x is equal to E of x square minus E of x the whole square. So E of x is equal to, E of x square is equal to 1300 by 100. And E of x means, here we find the mean value, that means 354 by 100. So we apply 354 by 100 the whole square. So we get variance x is equal to 0.47. And the next problem, show that the probability P of x is equal to x is equal to 1 by x into 1 plus x, and x varies from 1, 2, 3, etc. and 0 otherwise. First we find E of x is does not exist. So first we check the condition. Now we prove E of x is does not exist. That means to prove E of x is divergent. The E of x is does not exist. We get E of x is divergent. So the given we have the E of x formula, that means mean formula. E of x is equal to summation j equal to 1 to infinity xj into p of xj. So E of x into P of x value 1 by x into 1 plus x. Here x cancel. So we get summation 1 by 1 plus x. To apply the value x from 1, 2, 3, etc. First to apply 1. 1 by 1 plus 1, 2. So 1 by 2 plus next we apply 2. 1 plus 3. 1 plus 2, 3. So 1 by 2 plus 1 by 3 plus 1 by 4, etc. So to add 1 and subtract 1, we get the 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus etc. We take the value in 1 by n. Here n is equal to 1, we get 1. Next n is equal to 2, we get 1 by 2. N is equal to 3, we get 1 by 3. So E of x is equal to 1 by n and the minus 1. So here E of x is does not exist. So the E of x is divergent. That means E of x have no values. So the E of x is divergent, does not exist. Next we see continuous random variable. The all four problems are based on discrete random variable. Next we see about continuous random variable. The random variable x is said to be continuous random variable if it can takes all values between certain limit. That means the value x value this is the x value takes certain limit values only. It's called continuous random variable. The continuous random variable also have probability density function and mean and variance also. So the if x is continuous random variable, then f of x is called probability density function. Here the probability density function satisfies three conditions. First one is f of x greater than or equal to 0, and second one is this is continuous random variable. So integral minus infinity to plus infinity f of x dx is equal to 1, and third one is p of a less than or equal to x less than or equal to b is equal to integral a to b f of x dx. Here also have cumulative distribution function. The cumulative distribution function is denoted by capital F of x. Here also the cumulative distribution function is denoted by capital F of x is equal to minus infinity to x f of x dx. Minus infinity is starting value and x is ending point, ending limit value. Next the mean formula for mean. Mean is E of x is equal to mu is equal to integral minus infinity to plus infinity x into f of x dx. And the variance formula is variance of x is equal to sigma square is equal to E of x square minus E of x the whole square. Here the formula for E of x square is minus infinity to plus infinity x squared f of x dx. So we see the problem based on continuous random variable. First problem, the probability density of a random variable x is given by f of x is equal to x and x varies from 0 to 1, and the next value is k of 2 minus x and x varies from 1 to 2, 0 otherwise. So we find the value of k, distribution function, p of 0.2 less than x less than 1.2 and conditional probability value. So now we find the four division. First the given function f of x is equal to x, 0 less than x less than 1, and k of 2 minus x, 1 less than or equal to x less than or equal to 2, 0 otherwise. First we find the value of k. So we use the probability. We have to use probability density function. The formula is integral minus infinity to plus infinity f of x dx is equal to 1. So here 0 the values is varies from 0 to 1, 0 to 1 and the value of f of x is x, and 1 to 2 the value of f of x is k into 2 minus x. So the limit varies from 0 to 1 f of x dx plus 1 to 2 f of x dx is equal to 1. So the f of x value is 0 to 1 x. So integral 0 to 1 x into dx plus integral 1 to 2 k into 2 minus x into dx is equal to 1. So we integrate with respect to x, we get x squared by 2, the limit is 0 to 1, plus k is constant value, so we get outside to differentiate 2 minus x. So 2x minus x squared by 2, to apply the limit value 1 to 2 is equal to 1. So to apply the upper limit 1 squared by 2, that means 1 by 2, minus 0 by 2 is 0. So 1 by 2 plus k into upper limit value 2 into 2, that means 4, minus 2 squared is 4, 4 by 2, minus lower limit value 1. So 2 into 1, 2, 2 minus 1 squared means 1. So 2 minus 1 by 2 is equal to 1. So 1 by 2 plus k into 2 minus 3 by 2 is equal to 1. So 1 by 2 plus 2 into 2, 4. So 4 minus 1, 1 4 minus 3 1, so 1 by 2 plus 1 by 2 into k is equal to 1, so 1 by 2 into k is equal to 1 minus 1 by 2. So 1 by 2 into k is equal to 2 minus 1 by 2, 1 by 2. So k is equal to 1 by 2 into 2 by 1. So we get k is equal to 1. Next we find a distribution function of f of x. So we use the cumulative distribution function formula. Capital F of x is equal to integral minus infinity to x f of x dx. So first we check the limit values x less than 0, 0 less than x less than 1 and 1 less than or equal to x less than or equal to 2 and x greater than 2. So we check the 4 integral values. First we check x less than 0. X less than 0 means the cumulative limit is occur. F of x is equal to minus infinity to x f of x dx. So x less than 0, here no f of x value. So the value is 0. Next we apply 0 less than x less than 1. So the limit varies from minus infinity to 0 and 0 to x. Minus infinity to 0, here no f of x value, so the value is k, and 0 to x is f of x, the value is x, so we apply x. So integral 0 to x, x into dx. To integrate the x, we get x squared by 2. To apply the limit value 0 to x. So to apply x is equal to x, we get x. So x squared by 2. Next we check the limit value 1 less than or equal to x less than or equal to so. So the limit value is varies from minus infinity to 0, 0 to 1 and 1 to x. So here minus infinity to 0, there is no f of x value, so the term is 0, and 0 to 1 f of x dx value is f of x value x, and 1 to x k of 2 minus x into dx. So to integrate the x into dx, we get x squared by 2. To apply the limit value 0 to 1 plus k into 2x minus x squared by 2, the limit value is 1 to x. So we apply the upper limit value 1. So x is equal to 1, we get 1 by 2. 0, we get 0. So 1 by 2 plus k into, we apply x is equal to x, we get the same value 2x minus x squared by 2 minus lower bound value. So x is equal to 1, we get 2 minus 1 by 2. So 1 by 2 plus k into 2x minus x squared by 2 minus 2 into 2, 4. 4 minus 1, 3. So minus 3 by 2. 1 by 2 plus k into, we take a common LCM 2. So 4x minus x squared by minus 3 by 2. So 1 by 2 plus k into k, to apply the value of k is equal to 1. So 4x minus x squared minus 3 by 2. So we get minus x squared by 2 plus 2x minus 1. Next we check the limit value x greater than 2. X greater than 2 means the limit value is varies from minus infinity to 0 plus 0 to 1 plus 1 to 2 and 2 to x. So apply the f of x values, we get f of x is equal to 1 by 2. Next we check the condition p of 0.2 less than x less than 1.2. So we have to use probability density function formula. P of a less than or equal to x less than or equal to b is equal to integral a to b f of x dx. So here 0.2 less than x less than 1.2. So we take the between value 0.2 to 1.2, middle value is 1. So we take the value integral 0.2 to 1 f of x dx plus 1 to 1.2 f of x dx. So 0.2 to 1, the f of x value is x, and the next one is k into 2 minus x into dx. So integrate the values, we get the value 0.66. Next we check the conditional probability condition. P of a divides b is equal to P of a intersection b divided by P of b. So P of 0.5 less than x less than 1.5 and divides x greater than 1. Here a is 0.5 less than x less than 1.5 and b is x greater than 1. So we apply the formula P of 0.5 less than x less than 1.5 intersection x greater than or equal to 1 divided by P of B. P of B means P of x greater than or equal to 1. So the middle value is 1. So P of 1 less than or equal to x less than or equal to 1.5 divided by P of x greater than or equal to 1. We use first we find the numerator value. P of 1 less than or equal to x less than or equal to 1.5 is equal to integral 1 to 1.5 k into 2 minus x into dx. So here k is the constant value and also k equal to 1. So we apply 2x minus x squared by 2. The limit varies from 1 to 1.5. First we apply the upper limit minus lower limit. So we get 0.375. So next we calculate the denominator value P of x greater than or equal to 1. So x greater than or equal to 1 means the x varies from the limit varies from 1 to 2. So 1 to 2 f of x dx is equal to integral 1 to 2. F of x value is the limit value 1 to 2 varies from the f of x value is k into 2 minus x into dx. So we integrate the value, k is constant and also k is equal to 1. So 2x minus x squared by 2, the limit varies from 1 to 2. First we apply the upper limit, 2 into 2 4 minus 2 squared is 4. So 4 minus 4 by 2 minus lower limit 2 into 1 2 plus 1 square means 1. So 4 minus 4 by 2 minus 2 plus 1 by 2. So is equal to 2 minus 3 by 2. So we get fraction 4 minus 3 by 2 is equal to 1 by 2. 1 by 2 is equal to 0.5. Now we apply the numerator value and the denominator value in equation 1. We get 0.375 divided by 0.5 is equal to 0.75. Thank you all of you.